This session is Write Once, Run Everywhere. This is Wei Xiao, Technical Evangelist of Samsung Developer Relations Team. Co-presenting with me today is Schaller. Thank you. So this is what we will cover today. We will introduce to you Samsung's latest Gear products. And we will talk about how your notification solution can run across all wearable devices. Then we move on to the packaging part to see how you can package your app to support both Tizen wearables and Android Wear. We will also cover the porting between these platforms. As a wrap-up, we will walk you through the UI, UX details you need to take into consideration when you design your wearable application. 2014 is probably the boom year for smartwatches. Smartwatch is no longer an accessory that's associated with tech geeks. From displaying notification, to running apps, to monitoring your health rate, the latest crop of smartwatches does a lot more than just telling your time. For developers, this presents an opportunity, but at the same time, it's quite challenging to manage all your solutions. Our focus today will be Samsung's Gear devices rolled out during the past year: Gear 2, Gear S, and Gear Live. At the platform level, Gear 2 and Gear S run Tizen-based wearable platform, while Gear Live is powered by Android Wear. Platform aside, there are some common practice you need to follow to build your wearable solutions. Developing for wearables can be looked at from two different angles: notification and wearable application. Notification is the easiest way to get on your wearables. So if your Android app already uses a notification, notification can be bridged over to your wearable side without additional tweaks, and we call this bridged notification. This is what a standard Android notification looks like on your phone and your Gear device. This piece of code looks familiar to all Android developers. In the highlighted part, we simply use a notification compat builder to construct our notification. We define ticker, content title, content text. We also add a small icon and a background image. At the end, we define our content intent, which is a pending intent. We'll open a browser and redirects the end user to Samsung DevCon page. Once we have our notification, we simply call Notification Manager Notify to issue our notification. This is what end user will see on their device side. So let's move on to our first demo, Bridge the Notification demo. Can we switch to Almo, please? Thank you. So I'm using a Samsung device Note 3, which is paired up with Gear S and Android Wear device, Gear Live, at the same time. So I'm going to use my demo app to push a bridged notification to both devices. So this is what you will see on the Android Wear side. Icon, content title, content text. If you swipe, this is the big picture we embedded in our notification. Move to the other side is the default icon, action icon. So on Gear S, same thing. At the very top, let me move this a little bit to make sure you can see this. At the very top is the icon, followed by content title, content text. At the bottom, big picture, and default action button. Okay. Can we move back to the slides? So there are times when bridge notification is not enough. If you want to have more flashed out look in your notification, you probably want to use our latest Rich Notification SDK. There are some platform requirements for Rich Notification SDK. On the host device side, you have to use a Samsung device, which runs Android 442 API level 19 or above. On the wearable side, it has to be a Gear S. At this point, Rich Notification SDK doesn't provide backward compatibility on Gear 2 yet. So when you develop by using Rich Notification SDK, there are 3 jar files you need to include in your project. Rich Notification jar file, which is the jar file that includes all your Rich Notification APIs. JSON jar file, help you convert your Java object to JSON. So without this jar file, the content in your Rich Notification may not be parsed correctly. Our focus today is the bottom one, SDK jar file. This jar file will raise an exception during Rich Notification initialization stage if your platform doesn't meet basic Rich Notification requirement. Now I'm going to hand over to Anna to dive deeper into this jar file.
So one of the questions that we get all the time, is my speaker on? Can you hear me? Okay. One of the questions we get all the time is, how do I write one-to-one code base and run across all Android devices, not just Samsung specific? So about a year ago, we came out with this jar file, SDK v1.0.0.jar, that actually addresses that question. It's not just available for notifications, it's available for every single SDK that we have available on developer.samsung.com. So if you look at it, it's actually just an interface file. There's no code implemented in it. It has a set of 4 APIs: get version, initialize, is feature enabled, get version name. Each of these methods is actually implemented by the package itself. So for rich notifications, it's actually the details, the implementation is in the rich notification jar file. Same is true for all the other packages. Whoops, let me just finish. I think I lost my animation. Oh, there we go. Okay. So for rich notifications, what you need to do is make a call to initialize. If the device itself doesn't support rich notifications, it will fail on the initialize. So you have a try-catch block that will catch that failure. And if it's not supported, if it's not a Samsung phone, if it's not supported on that platform, do something else completely different. You'll get 2 exceptions: vendor not supported, device not supported. The other piece of this for the other packages is the call to is feature enabled. So not every package, not every SDK that Samsung has runs on every Samsung phone. For instance, the S Pen download only works on Note-enabled devices, so pen-enabled devices. So you would want to check to see initialize, to see if the framework actually supports it, or if the device actually supports it, and then call the is feature enabled to find out if the device supports that feature. Does that make sense? It's very straightforward. Okay, so that's the SDK jar file. That's how you write code once and runs everywhere.
Now we move on to our next demo, Demo 2, how you can use the same code base to manage both bridged notification and rich notification. Can we switch back to Elmo? Thank you. So here, I'm going back to my demo app. Bridged notification versus rich notification. So in this sample app, I'm actually sending out a bridged notification and a rich notification at the same time. and associate these two types of notification together. So on the device that supports both types of notification, for example, Gear S, user will not get duplicate message. One notification will be pushed over. On Gear Live, because it's an Android Wear device, you will only see breached notification. So both device buzzes. On Android Wear, this is the same thing you saw as in the previous demo. On the Gear S side, this is a rich notification created by using our rich notification template. It has 2 pages and default actions at the bottom. Now I'm going to run the same demo again on another pair of devices. This time is a Nexus 5 connected with Moto 360. Because Nexus 5 is not a Samsung device, rich notification initialization will raise the SSDK unsupported exception. So when I launch the app, you should be able to see a toast message at the bottom of the screen telling you rich notification is not supported. At the same time, breached notification will be sent over to Moto 360. So this is the toast message. Font is a little bit tiny. So if I click Demo 2, this is what you see on the wearable side. Okay. Can we switch back to the slides? So these are the tidbits you can use when you develop your notification solutions. But there are times when notification is not sufficient. For example, if you want to create a custom UI for your wearable, or you want to collect sensor data by using a wearable app, in both cases, you have to develop an app for your wearable side. So if you're interested in developing for wearable, we have a session at 1 p.m. today. Our engineer peer will be presenting all the details you need to know in order to develop a wearable application. In this session, we'll focus on the packaging part. I presume most of you have Android experience. So for Android developers, if you want to extend your Android app to the wearable space, the transition is actually easy. You have your phone APK ready, and you need to embed your wearable applications in your phone APK. So for Gear 2 and the Gear S, what you're going to embed is a Tizen WGT file. For Android Wear device, what you're going to include is an Android Wear APK file. So when you package for Gear 2 or Gear S, you have your Tizen wearable widget file. You need to copy this widget file over to your wrapper Android app assets folder. At the same time, you need to include one additional user permission in your Android manifest. Basically, this line integrates your application with the Gear Manager interface package. And the Gear Manager will know there's a widget file embedded in this APK. Same layout for Android Wear development. You have your Android Wear APK, and you need to copy it over to the resource raw folder of your phone APK. You need to add an Android Wear app description XML file to define your wearable app package name, version code, version number, resource path ID. Again, extend your Android manifest file by adding these 2 lines. It tells your phone APK you have an Android Wear app embedded, and because it uses Google Play service, the second line is required. Once you are done, you can submit the final phone app to Google Play. So now is the magic part. You can consolidate these 2 pieces and use one phone APK to support both Tizen Wearable and Android Wear. So consolidate all the pieces together. we have our Tizen Wearable WGT file copied over to the assets folder of your phone APK. Android Wear app APK copy over to resource raw folder. Resource XML defines your Android Wear app description, and you have to include additional permissions or metadata for both your Tizen Wearable and Android Wear. Once you are done, get your app submitted to both Google Play and Samsung's own App Store, Galaxy Apps. From consumer's perspective, on the left side, this is what consumer will see on Gear 2 or Gear S. When they download your app from Gear Manager, Samsung Gear Apps link, Gear Manager knows there's a widget file included in your phone APK. It will ignore your Android Wear APK, simply extracts the widget part and push them over to the Tizen Wearable installer. Same thing to Android Wear. It will ignore the WGT file embedded and only pick and choose the Android Wear APK, push it over. Quick recap of what you need to do when you distribute your app. For Gear 2 and Gear S, you need to integrate your Wearable widget file with your Android app by copying widget file to the assets folder of your phone APK. Get it submitted to Galaxy App Store. During the installation, Gear Manager assigns the Wearable widget file to the watch installer. Android Wear part. Wearable APK have to be copied over to the resource raw folder of your host APK. Get it submitted to Google Play Store. Android Wear interface package will send the wearable app to your watch. Now let's move on to our third demo, deploying a wearable application. So the app I'm going to show here actually uses the technique I just talked about. It includes both a wearable widget file, Tizen Wearable widget file, and the Android Wear APK. So during installation, Gear Manager interface package and the Android Wear interface package will pick and choose what they need to know and push them over to the wearable side. Can we switch back to Almo? So I'm still going to use my Note 3 that is paired with a Gear S device and an Android Wear device. Let's move to the application tray. So right now on my Android Wear side, I hope you can see this, I don't really have any applications installed. So on Gear S, move to the application tray. This is what I have now. So after this installation, you will see a new icon being created on both devices. So to make the presentation easy, I actually built an APK and copied it over to my SD card. So I'm going to install from here. You will see a pop-up message on the phone side, but this only happens when you sideload your app. So if you go back to the application tray on the Android Wear side, a new Demo Wear app icon is being created. It says Hello Square word. And on Gear S, this bottom icon is what we embedded in our phone APK. It basically creates a custom UI. Okay. Now, Anna will introduce to you how you can support multiple resolution in your code base. Switch back to the slides, please. Thank you.
Okay, so let's switch gears a little bit and take Android Wear off the table. We're going to focus right now on just the Samsung Gear S and Gear 2. They actually released this year at 2 different sizes, 2 different resolutions. So if you're an app developer, how do you create an app that runs on both of these? It's the same platform, but the display is slightly different. So if you look at the Gear 2, it's 320 by 320. If you look at the Gear S, it's 360 by 480. Different aspect ratios, 1:1 on the Gear 2, 3:4 on the Gear S. Resolution is 278 on the Gear 2, 300 on the Gear S. You do have to keep that in mind. You have to design your app correctly, or you will get a shadow box effect with your graphics. So this is on the Gear 2, hard-coded to the screen size of the Gear 2. This is what it shows up like on the Gear S. So how do you fix that? Use auto-scaling. So there's a tag in your widget file for your viewport. You need to define device width as opposed to hard-coding it at 320 or whatever the size, the screen dimensions are for the wearable. The other thing you need to do is use relative sizing for your UI elements. So don't hard code in the exact pixels that you want. Use percentages. This is pretty standard coding practices for any wearable or any smartphone. You want to make sure that your footers show up at the bottom of the page, so you don't want to code them to fit on a specific pixel. You want to make sure that the bottom is 0. Oops, and I guess that was it. So I'm going to switch it back to Wei.
Okay, so let's start with Gear 2 to Gear S migration. In many aspects, Gear 2 and Gear S are created equal. They use the same operating system, same SDK, same development tools. You probably have seen this before. For Gear S, there are 4 different development options: notification, clock face, widgets, and mini app. We already covered notification in the first part of today's session. If you want to decide for the other 3 options, there are things you need to consider because the form factor difference between Gear 2 and Gear S. This is a face-off between these 2 devices. Gear S has a bigger curved display. Gear 2 has a camera versus Gear S doesn't really have one. Connectivity-wise, Gear 2 supports Air Blaster, while on Gear S we support Wi-Fi, 3G, GPS. Gear S also packed more sensors into its hardware. So in your code base, if you want to differentiate which device you're using, you can use our system info capability calls. It can help you check hardware specs, for example, if GPS is supported on your wearable or if Wi-Fi is supported. If some of these features are mandatory to your application, you can include them in config.xml, so your app will only be visible to the devices that support this feature. For example, here, since my app requires location access, I include this line in my config.xml. When I submit my app to Galaxy App Store, my app will be only visible on Gear S, since only Gear S has GPS support. On the Android side, same Gear Manager can be connected to both Gear 2 and Gear S. Currently, we don't really have an Android API to check what your connected device is. So you have to use system info on your wearable side to check the different form factors, send it back to Android side to process. Another interesting topic is porting between these platforms. Although your wearables have very different form factors, probably run different operating systems, when you port your apps between your wearables, there are still a lot of things can be reused. First, wireframe. Your application screens, the relationship between these screens can be the same. You may need to adjust certain elements of your application, but certainly no overhaul is required. Interaction model. How you navigate from one screen to another. Is it a type or a drill down? When will your app send out a notification? This interaction model will stay the same. Data moved across the line will not change either. And you should be able to reuse most of your application resources, like high-quality art resources, your string resources. We have been working with Trulia to adapt their Android Wear app to the new Gear S platform. All the property images can be transferred over to the Gear S set without any adaptation. At the same time, do not replicate. It's important to respect each platform's conventions. For example, Tizen Wearable uses swipe down gesture to go back to the previous screen or terminate current app, versus on Android Wear, it's a swipe right. So do not change these default behaviors. Other conventions go deeper into the OS level. As a developer, you should build an app based on the mirrors of the platform. A successful app leverage what Tizen really excels, what Tizen performs differently, like security model, like UI framework. Our suggestion is you create a new WGT file based on your Android Wear logic when you port your Android Wear app to the new Tizen platform. To make your development work easy, if you're an Eclipse person like myself, when you install your Tizen Wearable SDK, there is bundled Eclipse inside. You can integrate your ADT plugin into your Tizen Wearable IDE, so all your development happens from the same environment. Now we have talked about the implementation part. We are switching back to the design part. What are the common practices you can use when you design your wearable application?
So we just have a few suggestions that are common across all the wearables that are coming out now. The first thing you want to do is keep in mind that these things are used very differently than your smartphone. So everything that you do on your wearable should be glanceable, quick in, quick out. More images, less text. People don't necessarily want to read long messages on their watch. Actionable. A single tap should get them somewhere. Don't make them tap 5 or 6 times to navigate to where they need to be and tap 5 or 6 times to get back to where they came from. Make sure your actions are short and concise and crisp. Get them where they need to go. You should also create a UI that's delightful, something that people want to look at. So be very creative in your graphics. Choose images that are relevant to your content. That's the first thing people will see. So if you have a picture there that reflects something that you would normally have put in text, you're going to get much more leverage. As Wei said, wireframe it, wireframe it, wireframe it. Know exactly where your users are going at all times and make sure that you make it easy for them. Don't make them swipe 5, 6, 7, 8 times to get somewhere. They will get very frustrated. Make sure that they can get back from where they came from. So if you push the power button, it actually exits the app, but make sure that you code within your app for places where they can go back a page or forward a page. One of the other things you should take advantage of is the buttons, the More option on the top of the header. It's kind of a non-intrusive way of giving them access to actions or places or things that they might want to do without visually getting in their way. It's kind of a replacement for buttons. You can put buttons on the screen, but this is a little bit more efficient way of doing it. Also, try not to do more than 5 pages at a time. You can go higher, but the more pages you have, the more you're requiring your user to work at getting information. So keep it minimal. Launch automatically if possible. Users don't want to have to scroll around a lot to find your app. Require zero to low interaction with the users. So as I was saying before, visually, if you can give them what they need in a picture or in a few words, do it. So we've been working with partners since, I guess, end of last year, beginning of this year, and we've started to compile a list of do's and don'ts. This is probably obvious. Wearable apps are not necessarily smartphone apps. So don't try and take your smartphone app and port it to the wearable space. It just frustrates users. The interaction model is different, the screen sizes are different. The way people use these things is very different. Take advantage of swiping motions. A back button is not necessary. So I would say you've got so little real estate, don't put a back button in. Use the swiping motions to go back from top to bottom or right to left. Build for offline mode. The Gear S actually does have Wi-Fi and 3G service, but not every wearable does. So you want to make sure that you're coding for the other cases, when you can't get to the internet or you can't get to a carrier service. Always be prepared. So that's pretty much it. I don't know if you guys have any questions on any of this. We are here today. At 11 o'clock is a second keynote upstairs. So after this, if you have some time, go and grab some coffee and head on up to the keynote room. We will be around all day for questions if you have them. So that's it. Thank you very much.
Thank you.